Every bridge, from the ancient stone arches to the modern cable-stayed bridges and even the movable bridges we have today, is an engineering marvel, with each one designed for a specific purpose and set of conditions. They are best understood by their classifications. In this video, we examine the classifications of bridges, breaking them down by their structural system, materials, span length, and function. By the end of this video, you'll clearly understand the different classifications of bridges. Welcome to the channel. What is a bridge? A bridge is simply a structure built to overcome a physical obstacle such as a river or a road, while allowing a passage beneath it. Bridges are classified into different categories to better understand their characteristics, and to carry out their design, construction, and maintenance. The various classifications of bridges include: classification by function or purpose. Some bridges carry cars and trains, while others are meant for pedestrians, utilities, and even animals. Based on this category, the major types of bridges are: highway or road bridges. These are the most common. They are designed for vehicles. Railway bridges. These bridges are built to withstand the heavy concentrated loads from trains. Pedestrian bridges. These bridges are built for pedestrians and cyclists, enabling transition from one place to the other. Another classification of bridges is the classification by structural form. Based on the structure, bridges are classified into: beam bridges. The simplest and most common type of bridge, perfect for short distances, primarily resists load through bending. In a typical beam bridge, loads are transferred from the deck to the girders, then to the support and finally to the foundation. Arch bridges. One of the oldest types in the world. Aside from its aesthetic appeal, the arch bridge is uniquely designed to be in compression, contributing to its strength and durability. Truss bridges. They are carefully designed to transfer vehicular loads to a network of interconnected members arranged in triangular patterns, known as trusses, which distribute forces and stiffen the overall structure, preventing bending and twisting effectively. Suspension bridges. The suspension bridges are made of high-tensile steel main cables that hang between towers in the form of catenaries from which the deck is attached by vertical steel suspenders. One of the most iconic is the Golden Gate bridges. Cable-stayed bridges. The newest of them all, the cable-stayed bridges similarly use cables, but unlike the suspension bridge, the cables are directly connected from the tower to the bridge deck in a harp-like pattern, increasing their aesthetics. Now let's see what bridges are made of. Classification by the material of construction. Materials greatly influence how a bridge behaves. Based on the material used, bridges are classified as follows. Stone bridges. They're strong and durable, like the ancient Roman arch bridges, which have lasted for millennia. Timber bridges. They are regarded as the earliest bridges. The simplest form were naturally fallen tree log across a stream, to modern timber bridges. Steel bridges. Steel is used in modern-day bridge design, such as truss, suspension, and cable-stay designs. They are strong, ductile, and capable of long spans. Concrete bridges. Concrete bridges are incredibly versatile and durable, and are the most common type built today, including the reinforced and pre-stressed concrete designs. Composite bridges. Many modern bridges are composite. They combine two or more materials, the most common being concrete and steel. Furthermore, some bridges are even built to move for navigation or clearance, which brings us to the classification by mobility. Bridges are classified based on their mobility and method of clearance for navigation as: Bascule bridges. In bascule bridges, the main girders, along with the deck, rotate upwards about a hinge located at one end of the span. Swing bridges. A swing bridge operates by rotating its deck horizontally around a central pier. This movement clears the waterway on both sides, allowing ships to pass through freely. Lift bridges. In lift bridges, towers or gantries are constructed at both ends of the span. The entire deck and girder systems are raised vertically by means of a hydraulic or mechanical lifting mechanism. Another way to classify bridges is by the interspan relationship. Based on the interspan relationship, bridges are classified as Simply supported bridges. In this bridge type, the total bridge length is divided into several separate spans. For each span, the load-carrying member is simply supported at both ends. Continuous bridges. In continuous bridges, the spans are joined together and run continuously over two or more supports. Cantilever bridges. Consists of structures that project horizontally from supporting piers. The ends of the cantilever are fixed. Furthermore, the length of a bridge can also determine how we classify it. Classification by the length of the span. The common classifications of bridges based on the length of a single span are: culverts. This is a bridge having a gross length of 6 meters or less. Minor bridges, having a length of 6 to 30 meters. Major bridges, having a length between 30 and 120 meters. Long span bridges, having a length above 120 meters. Another way to classify a bridge is the classification based on the position of the bridge floor. Bridges are classified as follows. Deck bridges, flooring on the top of superstructure. Through bridges, flooring at the bottom of the superstructure. Semi-through bridges, flooring at an intermediate level. Finally, bridges are also classified by how long they are expected to serve. Classification by the expected utility period. Based on how long they are expected to serve, bridges are classified into: temporary bridges, constructed for a limited period, like a few months or years, usually for emergencies, and are commonly made of timber or steel panels. Permanent bridges, properly designed and constructed for long-term use, often 50 years and above, they provide a durable and stable route for transportation for an extended period. They are usually made of reinforced or pre-stressed concrete or structural steel. Bridges aren't just structures, they embody the spirit of engineering. As technology advances, so will the bridges we build, lighter, smarter, and stronger. To achieve this, a proper understanding of bridge classification is essential. If you found this information helpful, please like this video, share it with your friends, and subscribe and turn on the notification bell for more engineering and metallurgical content. Thank you for watching, and see you in the next video.